topic is area between curves. When you first learned about how to use integrals to find area, you would have solved a problem that looked something like this. So the problem would have involved probably finding the area under a curve on a given interval where the curve sits entirely above the x-axis. So in this case, you're trying to find the area between the purple curve, y equals f of x, and the x-axis on between the vertical lines x equals a and x equals b. And of course that area would just be equal to the integral from a to b of f of x dx. So the problem is going to be instead to find the area between two curves like this. Here we have the purple curve on top, y equals f of x, and on the bottom we have the green curve y equals g of x given the same interval ab. In other words, between the lines x equals a and x equals b, we want to find the area between those curves. So the way to think about one way to think about it at least is by sort of analogy to a geometric problem you've probably seen. In this problem, what we have is we want to find the area of the shaded region, the orange region. And what we can see is that the orange region is all of the area inside of a 2 by 2 square, except for a circle of radius 1. So it's not too difficult to imagine that this is really a subtraction problem. Since we have two areas that we know how to find, so the area of a square and the area of a circle, we can just subtract one from the other. Clearly the area of the square, since the side of the square is 2, the area of the square is just going to be 2 squared or 4. And since this is a circle of radius 1, we know that the area of a circle is pi r squared. So the area of that circle is just pi times 1 squared, or pi. So in that case, the area of the shaded region is just going to be 4, the area of the square, minus pi, the area of the circle. So here we have the area of the square, we'll abbreviate SQ, and the area of the circle we'll abbreviate CIR. Okay, so we can do something fairly similar to find area between two curves in the xy plane. The way that you would think of it, if this drawing comes up, is suppose we want to find the area between the curves f of x equals x squared plus 1 and g of x equals 1/2 x on the interval from 1 to 3. So we certainly know how to find the area under the red curve, and we also know how to find the area under the green curve. So you can think of this as though we're just doing the same sort of subtraction problem, where we know how to find here the area under this curve, and if we subtract the area under the lower curve, then the result is going to be the area between the two curves. So I'll just write that out. Switch to a slightly different drawing. There we go. So we know that the area of the blue region, the area under the top curve x squared plus 1, is equal to the integral from 1 to 3 of x squared plus 1 dx, and we know that the area of the pink region is the integral from 1 to 3 of 1/2 x dx. So we can subtract them and simply write, sorry, it's not a very good equal sign. This is going to be equal to the integral from 1 to 3 of x squared plus 1 dx minus the integral from 1 to 3 of 1/2 x dx. But we can actually do a little bit more simplification than this, because what some of you may remember is that integrals are additive. So I can rewrite this by combining the two integrals this way as the integral from 1 to 3 of x squared plus 1 minus 1/2 x put some brackets around that, dx, and you'll see that what we're really doing is we're just finding the integral of the top curve minus the bottom curve. That's going to give us kind of the basic engine of how you find areas between curves. Obviously, we're going to get a little bit more complicated than that, but what we can do now is calculate the resulting integral. What we can do now is calculate the resulting integral, which gives us, just find all these antiderivatives. That's x cubed over 3 plus x minus 1/2 x squared over 2, from 1 to 3, and that is going to equal, this gives us 27 over 3 plus 3 minus 1/2 times the 1/2 gives us 4, so that gives us 9 over 4 minus 1/3 plus 1 minus 1/4, and we add all of that up and we get 26 over 3. And that's the area between those curves. Okay, so now it's your turn. I'm going to put a problem up. I'm going to put the diagram for a problem up, and it's your turn to find the area, the pink area, the area between the two curves shown.